Okay, people, hold it down. End of the world, take one. Anytime, Sydney.
At first, it looks like kind of a fireball. It grows bigger and bigger by the minute. Soon, it seems to be larger than the sun. People are frozen to the spot with their eyes glued to the sky. They haven't realized yet they have to run for their lives. Not that it's going to help. The asteroid slams into the planet with enormous force. It doesn't stop moving until it gets through the crust to a depth of several miles. Thousands of cubic miles of solid rock instantly turn into vapor. Everything and everyone close enough to see the crash don't live longer than a few seconds. The ground around the impact crater is covered with thousands of feet of hot ash, grit, and rubble. Mere seconds after the collision, grass, trees, and shrubbery for many miles away burst into flames. But that's not all. The crash sets off a series of natural disasters, like tsunamis. What didn't burn down within the first several minutes gets flooded. In some places, tsunami waves are higher than 1,000 feet. Earthquakes start to shake the planet. Less than an hour after the asteroid crashed into the planet, a gust of wind whips through the world. Its speed is more than 600 miles per hour. The hurricane flattens down everything that is standing and scatters debris for miles around. A bit farther away from the impact zone, the sky is starting to darken. That's why beautiful shooting stars seem even brighter. But those aren't stars. That's debris raining back on the planet. They re-enter Earth's atmosphere glowing ominous red because of the infrared radiation. These are just the first hours after the crash, but the sky is almost completely black. By the time it begins to get lighter, there's no life on the planet. The ash is still in the air. When it rains, the water gets highly acidic. Fires keep raging. They produce tons of toxins that destroy the ozone layer. Earth loses its last shield against the radiation from the sun.
Okay, I don't like that one. Too much doom and gloom. What else we got?
Well, or the end of the world could look quite different. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the sun. The climate all over the planet starts getting colder and colder. It becomes impossible to live close to the poles. All life gathers near the equator. Quite soon, half of the planet turns into an icy desert. There's a lack of food and other resources. It's getting darker and darker. There's not enough light for plants to get energy. They wither, and animals that used to feed on them can't find food and go extinct. The farther our planet is from the sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth gets too far away from its main source of light and heat. It turns into a lifeless piece of rock covered with a thick layer of ice.
Nah, I don't like that ending either. Leaves me cold. Anything else?
Or the sun might expand and turn into a red giant. If it happens, it'll change the entire habitable zone of the solar system. It starts when our star runs out of the hydrogen in its core. This triggers several reactions. In the end, the core heats up and gets denser, which makes the sun way larger. During this transformation, the sun swallows Venus, Mercury, and Earth. The expanding star engulfs our planet even before it reaches the tip of its giant red phase. It still has around 500,000 years to grow. As soon as Earth is inside the sun's atmosphere, its orbit changes. The planet spirals inward, inside the star's raging heat. But no one and nothing is around to witness it. Long before that, the sun evaporates all the oceans on our planet. In the end, Earth becomes molten. Molten, huh? Nah, that's too hot to try. Try again. Okay. Or it might be something vastly different. People all over the world wake up in the middle of the night. It's as light as in the morning, but it's not sunlight. The skies are illuminated with countless auroras, red, green, purple. They appear even in the regions where no one has seen them before, like the Bahamas, Jamaica, or Hawaii. The sun is a gigantic, constantly changing ball of burning gases. Every once in a while, it spews out bursts of energy. Those are solar flares. They are often accompanied by coronal mass ejections. So, this time, the Sun has produced an epic geomagnetic storm and unleashed it at our planet's protective layer. Waves of charged particles slam into Earth's atmosphere. The planet's magnetic field isn't powerful enough to stop this. It gives way, and the storm hits Earth, causing havoc. It starts by disrupting GPS and knocking out satellites. After that, the storm interferes with satellite communications. But one of the worst consequences is connected with power grids. Power surges caused by the particles coming from the Sun damage giant transformers. Earth is left without electricity for years. There's no light, no computers, no phones. Water supply systems are out of order. There's no food in supermarkets. There's no electricity, and people can't reboot the already broken power grids. Wildlife takes over the planet, creating some kind of a post-apocalyptic world.
Yeah, I think we should let the monkeys run things for a while. They can't do any worse. Alright, what else?
Ooh, if you had the gamma ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, then disappear again. Those flashes are gamma ray bursts. One of them might wipe out Earth's atmosphere. The flash that's going to ruin our planet was born in a faraway galaxy where two collapsed stars merged. It's immensely powerful. It carries 10 quadrillion, which is 1 followed by 16 zeros, times as much energy as our Sun. When the burst is 1,000 light-years away from Earth, it's already shining as bright as our Sun. Our planet's atmosphere is trying to protect us once the burst comes too close. But this shield doesn't last. The radiation is so powerful that it literally cooks the atmosphere. It creates nitrogen oxides that destroy the ozone layer. Without this layer, ultraviolet rays coming from the Sun hit Earth's surface at full force. They wipe out tiny plankton in the ocean. These plankton produce from 50 to 70% of all oxygen on our planet. They disappear, and soon there's a severe lack of oxygen. Terrestrial life vanishes first. After that, living creatures start to disappear from seas and oceans. In the end, the heat and ultraviolet light coming from the Sun turns the planet into a huge chunk of barren rock.
Never mind, I don't like any of these. Let's just keep the Earth the way it is, okay? Hey, Sydney, why don't we blow up Mars or something?
Hey, listen up. There's a red alert. NASA supercomputers have calculated that there are only 2,021 years left until the end of the Earth. Our planet is about to… Oh, wait a minute. Oops, I'm sorry. I thought these zeros were a mistake. Well, the research actually says 1,000,000,2021 years in the future. Woo, that's a relief. Breathe normally. Still, this means that our planet officially has an expiration date. And no, this is not science fiction. It's a very real study that shows how, why, and when life on Earth will end. So, thanks to NASA and Japan's Toho University, we can now mark the calendar. It'll happen in around 1 billion years. But what about how and why? Well, even as recently as the early 20th century, scientists still didn't know what powered the Sun. One of the first big ideas was that the Sun was basically a giant piece of charcoal, just a huge ball of fire burning some kind of fuel. But that was easy to rule out. At the rate the Sun puts out energy, it would have burned through that kind of fuel in just a few thousand years. And even back then, geologists and paleontologists already agreed that Earth was at least 100 million years old, if not more. That meant the chemical burning couldn't have possibly kept the Sun shining for that long. So, scientists turned to another, more nerdy theory – gravitational contraction. This idea was that the Sun shines because of its own weight. Its gravity pulls all the gas inward, squeezing itself tighter and tighter. It's kind of like warming your hands by rubbing them together. We know that gas giants like Jupiter and Saturn are slightly contracting under their own weight and giving off more heat than they get from the Sun. So yeah, gravitational contraction, also known as the Kelvin-Helmholtz mechanism, is very much real, but it's not what powers the sun. When researchers did the math, it showed the sun could only shine like that for about 20 to 30 million years. Eventually, scientists learned that the real secret behind the sun's power and longevity was something way more powerful – nuclear fusion. Now, deep inside the sun, it's unbelievably hot. We're talking 27 million degrees Fahrenheit, and it's under crazy pressure because the sun is so big and heavy. All that heat and pressure squashes hydrogen atoms and forces them to stick together. When 4 hydrogen atoms get squished hard enough, they turn into something new, a helium atom. When that happens, a little bit of their mass turns into energy, and that's what becomes sunlight and heat. For centuries, people feared the sun would someday go cold, and that will happen, eventually. About 5 billion years from now, our star will run out of hydrogen, and gravity will take over. But long before that, Earth will already be toast. According to a NASA life extinction prediction, our planet will become a scorched, uninhabitable rock, not because the sun will go out, but because it will burn too hot. It turns out that those old apocalyptic ideas were not completely off. The sun will destroy life on Earth, just not by going cold. But why? Well, it's because, with time, the sun is getting brighter. And I'm not talking about its mood. It releases more energy. It's a slow, natural side effect of the nuclear fusion we just mentioned. Deep in the core, the sun has been fusing hydrogen into helium for billions of years. But as more helium piles up, the core gets denser and hotter. Think of it like a pressure cooker. The more pressure builds up inside, the more heat rises from within. That extra heat speeds up fusion, which means more energy gets released, and the sun starts shining just a little bit brighter. It's not dramatic, we won't notice it in a lifetime, but the future-proof androids we're going to build just might. With time, the extra heat adds up. The sun is already about 30% brighter than when the Earth was born. But life decline is going to happen much earlier, even before the given deadline. As the sun keeps cranking up the heat, Earth is gonna sweat. The extra sunlight raises global temperatures to the point where the ocean surfaces hit around 117 degrees Fahrenheit. That's hot enough to mess with the planet's entire climate system. Water vapor begins to rise from the oceans and accumulate in the upper atmosphere. This causes even more heat to be trapped, creating a thick, humid layer around Earth. Scientists refer to this ongoing cycle as the moist greenhouse effect. The rising temperatures aren't just drying out our planet, they're also harming plants. Plants rely on carbon dioxide from the air to grow and thrive. However, as Earth warms up, certain natural processes can take too much carbon dioxide out of the atmosphere. When that happens, there won't be enough CO2 left for plants to survive. Forests will disappear first, then grasslands, bushes, and even the toughest plants that usually handle extreme heat. This all will lead to oxygen collapse, because plants and CO2 are crucial for photosynthesis. In simple terms, this is how plants use sunlight, along with water and carbon dioxide, to create their own energy and produce oxygen as a waste product. Right now, oxygen makes up about 21% of Earth's atmosphere. But once it drops below even 1%, complex life as we know it will most likely disappear. Earth's biosphere will shrink to just a few microbes and extremophiles, hiding deep underground. But even they won't last long. It's worth noting that scientists ran 2 versions of the simulation, one with life like we have today and one with none at all. Surprisingly, both worlds lost their oxygen at about the same time, around 1 billion years from now. That means plant life and photosynthesis do help, but they're not the main thing keeping oxygen in the atmosphere. It's actually a long-term chemical battle between volcanic gases and rocks that gradually soak up oxygen like a sponge. And even after most life is gone, the heat will keep going, causing oceans to boil. Not all at once, but slowly and steadily, the oceans will begin to evaporate into the atmosphere. But that vapor won't just come back down as rain like it does now. Why? The atmosphere will be too hot and thick for that. Instead, sunlight will start breaking the water apart, and hydrogen will escape into space permanently. Once it's gone for good. Basically, instead of raining back down, Earth's water will slowly leak into space until there's nothing left. Even before the last puddles vanish, life under the sea will be long gone. Once the balance of temperature and oxygen is lost, not even the hardiest ocean life can hold on. In the end, Earth will become something we can barely recognize, a dry, lifeless rock. There will be no water, no oxygen, and no life left. The oceans will be gone. The atmosphere will be thin and toxic. Even the most resilient microbes will have disappeared. However, the sun will still shine in the sky. Earth will keep orbiting just like always. It'll still be a planet, just without life. But long before that cosmic finale, Earth will already be uninhabitable, which raises the big question. So, what could future humans do about all this? Well, escaping sun radiation and extinction might end up being humanity's biggest engineering challenge yet. Maybe we'll build massive space colonies and leap from planet to planet, staying just ahead of the sun's deadly heat. Even if we terraform Mars, making it more Earth-like so we can inhabit it, it'll still be cooking in the same solar oven, just on a lower shelf. Or maybe we'll live in giant rotating space habitats, like O'Neill cylinders, floating mini-worlds with gravity and recycled air, water, and energy to support long-term survival. Those could drift farther and farther from the sun as things heat up. Or who knows, maybe we'll upload our minds to the cosmic cloud or hop into a higher dimension and watch the universe like it's, Netflix. Okay, this is definitely too nerdy, and we're going deep into sci-fi territory. But whatever the solution may be, humankind has a long time ahead to figure out how to survive the eventual end of Earth and life, or maybe even preserve it, in whatever form it takes. So, in the end, will the sun be to blame for destroying our planet? Or how about a huge meteorite? Or some kind of disease? Probably not. It seems that life will disappear for a very unexpected reason. Humans, animals, insects, fish, and most microbes will be wiped off the face of the Earth because of oxygen, or more precisely, because of its absence. Recent research has shown that the number of freshwater reservoirs with very low or no oxygen levels in coastal areas is increasing worldwide. Over the past 65 years, 4 times more oxygen-deficient waters have appeared in the world's oceans. What does it all mean? It's likely that life on Earth will vanish much sooner than the sun's energies dries up all the oceans. The end is likely to come in a little more than 1 billion years. But this doesn't mean that the planet will disappear too. The period when Earth is filled with oxygen will make up just about 20 to 30% of the total lifespan of the planet. So we're just temporary guests here. Just think how long that is, 1 billion years. The first Homo sapiens appeared only about 300,000 years ago. That is, the entire history of humanity occupies less than 500,000 years. So relax. 1 billion years won't pass very fast. By that time, humans won't be on Earth anymore. We might master space travel and find a new planet in the vast depths of space. But why can we lose air? As the sun heats up, the planet gets warmer and warmer, and this heat breaks down carbon dioxide, the gas which is necessary for all plants to photosynthesize. Without carbon dioxide, they can't produce oxygen. With a drop in carbon dioxide levels, the methane content will increase, and this gas is quite harmful to us. Now, this all sounds logical, but this is a secondary reason for the lack of oxygen. The real problem is something else entirely. As the sun becomes brighter, it will begin to heat rocks on Earth, such as granite and basalt. These rocks will start to break down faster. When they collapse, they take carbon dioxide from the air, which warms our planet. If there's less carbon dioxide in the air, Earth should become colder. But there's a problem. The sun will shine more, and its heat will outweigh this cooling effect. So even if rocks take away carbon dioxide, the sun will blaze so much that Earth will still become extremely hot. Next, when the sun shines more intensely, it, along with other natural factors, contributes to the breakdown of granite and basalt. These rocks mix with carbon dioxide and water to make carbonates, which go deep into the earth. This takes carbon dioxide out of the air, which means plants can't make as much oxygen because they need carbon dioxide to do that. Besides, volcanoes release gases, which also reduce the amount of oxygen in the air. So the sun, by destroying rocks, affects what happens inside Earth and controls how much oxygen there will be in the air. In about 1 billion years, the sun will become so bright that no rocks will be able to save Earth from its heat, and the escaping gases will halt photosynthesis and oxygen production. And then, our planet will return to the state it was in about 2.4 billion years ago, to the time when the Great Oxidation Event began. And this event was much more important than, say, the first Olympic Games or the appearance of humans on the planet. Billions of years ago, there was almost no oxygen on Earth. Instead, there was a soup of gases, such as nitrogen, ammonia, methane, carbon dioxide, and others. Yes, we have these gases in the atmosphere today, but there used to be a lot more of them in the past. It was difficult for any form of life to originate in such conditions. But after some struggle, it succeeded. At first, Earth was inhabited by the simplest bacteria, including cyanobacteria. They learned how to make oxygen using sunlight, water, and carbon dioxide. These bacteria worked for millions and billions of years and made so much oxygen that it began to accumulate in the air. This was what we now call the Great Oxidation Event. It was like a great celebration of life, because with oxygen, new living beings could appear. But by the way, cyanobacteria didn't learn photosynthesis because they were like, oh, let's make oxygen, it's so cool. No, oxygen was just a byproduct. Cyanobacteria wanted only one thing, to get as much energy as possible. And for this, they learned photosynthesis. It helped them store energy using sunlight. They used special pigments to absorb light, and the result of this process was the release of oxygen. This had been going on for hundreds of millions of years, and then, at some point, they made too much oxygen. This oxygen started to spoil other gases that had been there before. For example, it ate a lot of methane. Because of this, Earth cooled down a bit, and the Ice Age began. But that's another story. In short, in 1 billion years, we risk going back to that difficult time. But let's hope that we'll manage to move to another planet on our spaceships or come up with some other solution. And what'll happen to our home planet next? Will new life be able to originate there without so much oxygen? Well, it's possible, but it'll be much more difficult. This will require another source of energy besides the sun. It can be, for example, hydrothermal vents. And by the way, there are ecosystems on Earth that use this type of energy. You can find one of them in the Mohole cave in Romania. Imagine a place where there's little oxygen. It's dark. The sun's rays don't reach there. Over millions of years of evolution, a unique and slightly creepy life has developed in this cave. It was first discovered in 1986, and scientists are still exploring this place. The entrance to the cave is just a small hole in the ground. A narrow tunnel goes deep underground. Inside the cave, the air is filled with hydrogen sulfide and carbon dioxide, and there's half as much oxygen there as on the surface. A human can't stay there without a special mask. But for local forms of life, this is home, and they feel great there. There are several dozen species living in the cave, and many of them aren't found anywhere else on Earth. Here you can see strange little monsters, white snails, white spiders, centipedes with long whiskers, transparent shrimp, and even unknown species of leeches. Since there's no light in the cave, all these creatures don't need eyes. They're blind, but they have long sensitive antennae and paws that allows them to navigate in the space. They also have no colored pigment, so all these bugs and spiders are either white or transparent. But if there's so little oxygen there, and nobody does photosynthesis, then how does all this life survive? It's all thanks to the unique bacteria autotrophs. They absorb carbon dioxide and produce nutrients. These bacteria are food for other organisms, and those, in turn, become food for larger creatures. So a whole food chain has been built in the cave, which provides all the inhabitants with food. Evolution has created a unique ecosystem that exists separately from the rest of the world. It's like a small universe that has developed according to its own rules. However, this universe is not expanding, because all living beings here can't live away from hydrothermal vents and autotrophs. Otherwise, where would they get their energy from? But let's imagine that the sun cools down, almost all the oxygen disappears, and the entire planet gets covered with hydrothermal vents. It's dark, and the air is filled with methane, CO2, and other substances. And somehow, life begins. Even people appear at one point. What would they look like? Pale, thin, and blind creatures with very long arms that help them navigate in space. They have pets, large centipedes or cockroaches that move silently on the ground. People are also quiet because they don't have lungs filled with air to scream. There's silence in the world. People communicate through touch. No one travels. Everyone lives separately next to their hydrothermal source. The whole world has turned into a horror movie in a billion years.
It's one small step for man, giant leap for mankind.
In the late 1950s, everyone was captivated by space exploration. But there was a group of rebels who wondered not what's out there, but what's down there. This team called themselves the American Miscellaneous Society. Yes, that's their real name. And they started one of the biggest projects ever, Project Mohole. Joyful and determined, they had no idea what a nightmare they started. First, let's understand what the project was about. You probably know that Earth is like a giant onion. If you cut it in half, you'd see it's made of layers. Each one is different from the next. The crust is what we all stand on. It's incredibly thin, like the skin of an apple. It's made of tectonic plates, almost like puzzle pieces, and they float on the layer beneath. That layer is the mantle. It's mostly solid, made of rock, but these rocks flow and move very slowly, just a little bit over thousands of years. They're also incredibly hot, thousands of degrees Fahrenheit, so it's a bunch of scorching stones moving around like caramel syrup. And when the mantle moves, the tectonic plates above move as well. Usually, this movement is slow and harmless. We don't even notice it. But sometimes they can bump into each other, get stuck, and so on. And when they do, they send such horrifying vibrations through the ground that they're hard not to notice. These vibrations are called seismic waves. In 1909, a Croatian scientist, Andrija Mohorovičić, noticed something weird. Turns out, at a certain depth, seismic waves suddenly speed up. He didn't yet realize that he stumbled upon a boundary between the crust and the mantle. It became known as the Mohole boundary. Now try to guess what the Project Mohole guys decided to do. It was during a meeting of the National Science Foundation. Everyone was discussing current scientific progress. Suddenly, Walter Munk, a geophysicist and oceanographer, casually threw out a take that shocked the room. Why not drill all the way down to the mantle? His idea was outrageous. Drill through the ocean floor, deep into the planet's skin, reach the Mohole, and see what it's all about. Never mind the fact that the ocean is crazy deep with crushing temperatures and violent currents. Super bold, but not entirely out of nowhere. If we start from the ocean floor, the Mohole lies just about 3 to 6 miles below it. It's much easier than starting from land. That would require digging from 10 to 60 miles deep. That made the oceans the best bet for reaching it. Munk wasn't the only one. Harry Hess, one of his colleagues, was just as excited about the time. At the time, people didn't know much about plate tectonics. Hess was one of the founders of that theory, believing that the world is made up of giant moving plates. To him, it was great. Drilling to the mantle would give him evidence to prove that theory. They became a team and found more like-minded scientists. They combined the most brilliant minds in earth science: Roger Revelle, Maurice Ewing, and Arthur Maxwell. They called themselves miscellaneous because there were all sorts of scientists in the team. Poor guys didn't know that their playful name would later come back to haunt them. But the NSF was dumbfounded by their idea at first and rejected it, because duh, it would be a nightmare to pull off. So our team secured $50,000 just to make a plan. Then they presented the official banner. Luckily, science was on the rise, and there were rumors about other countries trying their own deep drilling projects. So the AMS got the green light this time. The plan consisted of 3 phases. Phase 1. Do a drilling test. Check how things are going. Phase 2. Build an intermediate drilling vessel. Phase 3. Keep going until they reach the Mohole. And they got a funding of a whopping $2.5 million. And finally, in March and April 1961, the project finally began. Phase 1 took place off the coast of Guadalupe Island, Mexico. They used a converted barge called Cuss-1 and some insane brain moves to make it work. Originally, Cuss-1 was made for drilling oil offshore. It was one of the best things we had for drilling in deep water. But a catch was that it could only go a few hundred feet down. And remember, we need at least 3 miles. The team had to come up with something revolutionary: dynamic positioning. It's a tech that allowed the ship to stay perfectly still in the middle of the ocean, even without an anchor. It worked like this. They dropped 6 buoys into the water, forming a circle around the ship. These buoys sent underwater echoes to help the ship understand where it's located. Using motors and a joystick, the crew could keep Cuss-1 right in the center of the circle. And surprisingly, they started making progress. Even though ocean drilling is incredibly hard, they drilled through thick layers of sediment and reached an astonishing 600 feet below the seafloor, about 2 Statues of Liberty. And the seafloor itself was almost 12,000 feet deep. This was just the beginning. Deep down, they stumbled upon tons of basalt, a type of volcanic rock. It doesn't surprise us now, but for that time, this achievement was groundbreaking. Turns out they got through Miocene-age sediments, rocks formed millions of years ago. This discovery told us so much about the history of our planet. Now the entire world held its breath. Even the famous writer John Steinbeck, the author of East of Eden and The Grapes of Wrath, got caught up in the excitement. He joined the project and wrote a dramatic article about it for Life magazine. He wrote that we knew less about the ocean floor than we knew about the moon. That line stuck. The biggest surprise was that President John F. Kennedy sent a telegram congratulating the team. It's like the space race turned into inner space, and for a brief moment, it looked like they just might do it. But years later, Walter Munk said that the very success of Phase 1 doomed the project. The early triumph raised expectations sky high. From the start, the miscellaneousness of this society led to tons of disagreements, logistical hurdles, and the costs just kept rising. When the NSF realized just how successful the project was, they took over in 1961. The original society became just an advisor, and this completely screwed things up. One of the scientists said that it was a lengthy and unattractive trail of bickering, bitterness, and short-sightedness. They wouldn't even decide what exactly they wanted to do and whether they even want to reach the Mohole. After that, the project found the new contractor company, Brown and Root, but it was a political decision, not a scientific one. Brown and Root had no experience in deep-sea drilling at all. Poor scientists had to suffer because this company didn't understand the project's goals and how hard it is. Some scientists even quit because of how annoying that was. As a result, when they calculated how much it would actually take to reach the Mohole, it turned out to be about $1 billion by today's standards. This shocked absolutely everyone. The public was mocking them, which didn't help at all. Some articles called it Project No Hole and gave titles like How NSF Got Lost in Mohole. The final blow happened in '66. The project's most loyal supporter, Albert Thomas, passed away. Plus, the situation in Vietnam was escalating. As a result, the project was stopped after eating up tens of millions of dollars. What's even worse, this giant, impossible idea took the funding from smaller and achievable things. But it wasn't entirely for nothing. Project Mohole pioneered a new deep-sea drilling technique, which is now standard. They also inspired many new, similar, smaller ideas. And science just kept going since then. In May 2023, scientists finally achieved this dream. They actually pulled up rocks not even from the Mohole boundary, but from the mantle itself. They got them from the bottom of the Atlantic Ocean. So maybe one day we'll be able to drill all the way down there.
Tick-tock. No, not the app, a clock. You see, scientists already know the exact doomsday date. Tick-tock. The countdown has started. We only have 250, no, not years, millions of years left on this beautiful planet we call Earth. Well, let me apologize first. I might have scared you with all these end-of-the-world things. You and I certainly won't live to witness it, but we already know when it will all go downhill, and most importantly, why. This 250 million years deadline is not precise. If we change our ways, humans can stick around for more or less, depending on what way we choose. Researchers ran some computer simulations and found that Earth might be left without any mammals if temperatures kept climbing to between 104 and 158 degrees Fahrenheit. What's the culprit? Well, it's mainly our love for fossil fuels and the greenhouse gases we keep pumping into the atmosphere. It's easy to think that mass extinctions are a thing of the past, especially since the last big one wiped out dinosaurs 66 million years ago. But surprise, we're actually overdue for another one, and this time, it's all on us. Throughout Earth's history, there have been 5 mass extinctions, and it's been 66 million years since the last one. But this upcoming one is special. It's totally human-made. As Earth's tectonic plates shift over millions of years, they eventually come together to form supercontinents. This could lead to some pretty serious natural disasters, and, well, it might as well mean the end. Having one continent instead of 7 is already pretty extreme, as it will totally make us rethink the way we live. Now, scientists said that a new supercontinent would create a trio of problems. The continentality effect. No, I didn't make that word up. A hotter sun, and rising CO2 levels, resulting in a super hot planet. This would lead to tough living conditions for mammals with limited food and water. If temperatures hit 104 to 122 degrees Fahrenheit, and maybe even more extreme fluctuations, humans and lots of other species would struggle to cope since we can't shed heat effectively through sweating. Some experts believe the future looks pretty grim. CO2 levels could end up being double what they are now, and the sun's radiation could increase by about 2.5%. With the supercontinent likely to be in hot, humid tropics, much of the planet could be facing extreme heat. Finally, in about 250 million years, Earth is expected to morph into a donut shape with a big inland sea in the middle, leaving the Pacific Ocean to cover most of the surface. Honestly, no matter how well scientists crunch the numbers, they can't see the future, especially when it's this far out. But hey, those who ignore history are doomed to repeat it. So let's jump into the history of the 5 massive extinctions that have already happened. The late Ordovician mass extinction hit around 445 million years ago and was a huge deal for ocean life, wiping out up to 60% of marine species, including 85% of all marine creatures. Unlike other extinctions, it really didn't change ecosystems much. It had 2 main phases. First, the climate cooled due to glaciation, causing sea levels to drop and many marine animals to lose their homes, leading to new cold water ecosystems. Then, when the ice melted, warming returned, but oxygen levels plummeted, creating toxic ocean spots. I know, it all sounds horrible, but let's see the results. The planet is still habitable, marine life is booming, and, by the way, there are even species, some hard-bodied arthropods like horseshoe crabs, that are still around. So from our perspective, it feels like it wasn't a disaster so much as a step for further development of our planet. But let's not make premature conclusions and take a look at the next mass extinction. The late Devonian extinction was a big deal in Earth's history, happening about 272 million years ago. The main event during this time was called the Kielwasser event, which wiped out about 19% of all family groups and half of all types of living things in the oceans. Another extinction, the Hangenberg event, occurred around 359 million years ago and marked the end of the Devonian period. This extinction wasn't just one event, but might have happened over a long time, possibly from 500,000 to 25 million years. Some scientists think that there were as many as 7 separate extinction events during this period. By the late Devonian, plants and insects were starting to thrive on land, and oceans were filled with huge coral reefs. The continents were also moving together to form what we know as Pangea. Most of the creatures that disappeared were in the oceans, like brachiopods and trilobites, especially the ones that built reefs. The reasons for this extinction are still a mystery. Some ideas include changes in sea levels, lack of oxygen in the ocean, global cooling, or even volcanic activity. There's also a theory that a comet hit Earth. Interestingly, it seems that the loss of diversity came more from fewer new species forming rather than a spike of species dying out. During this extinction, oceans became low in oxygen, which helped preserve some organic material. This, along with the porous rocks from that time, made Devonian rocks a valuable source of oil, especially in places like Canada and the US, way before they became Canada and the US. So far, these terrible mass extinction events don't sound that bad. Now, about 250 million years ago, there was a huge event called the Permian-Triassic extinction, often called the Great Dying. It was probably the worst extinction event ever on Earth. During this time, a whopping 59% of all biological families and 83% of different kinds of living things disappeared. This included 81% of marine life and 70% of land animals. Even insects were hit hard. Scientists believe the main cause of this mass extinction was massive volcanic eruptions in what we now call the Siberian Traps. These eruptions released a ton of gases, like sulfur dioxide and carbon dioxide, which messed up the oceans and made it hard for many creatures to survive. The atmosphere's carbon dioxide levels skyrocketed from about 400 parts per million to 2,500 parts per million. Other possible reasons for this extinction include burning oil and coal during these eruptions, intense weather patterns like El Niño, and even a possible asteroid strike. All of these factors combined, creating a really tough environment for life on Earth at that time. Okay, this one seems serious. Let's proceed though, shall we? The Triassic-Jurassic extinction event, happening around 200 million years ago, was a major wipeout of many species, both on land and in the ocean. In the oceans, between 23 to 34% of marine life vanished. On land, most reptiles, except for crocodiles, dinosaurs, and pterosaurs, those flying reptiles, went extinct. Some of the reptiles that went extinct were once very common. Luckily, plants, early mammals, and the groups that survived, like dinosaurs and pterosaurs, thrived and became the main animals for the next 135 million years. Scientists think this extinction might have been caused by huge volcanic eruptions, which released lots of carbon dioxide into the air. This led to global warming and made the oceans more acidic. The Cretaceous-Paleogene extinction event happened around 600. Oh boy. Scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now, since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So, the thing is, a massive volcanic eruption today could be even more devastating than the Year Without a Summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Somalus eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the The 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity, and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sunthunkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions.